Imagine you walk into a car dealership. You're there to buy the most affordable, sensible car on the lot, a basic commuter model, something practical. Then someone hands you the track results. And this everyday sedan just clocked faster times than the limited edition carbon fiber flagship sports car, the one that costs 4 times as much. That seemingly impossible scenario where budget just flat out beats flagship, that is exactly what just happened in the world of AI coding. A fast, incredibly cheap model just officially upset its own higher-priced sibling at solving real-world, messy engineering problems.
Welcome to the deep dive. And this isn't just an upgrade, it's more like a category collapse. We're diving deep into what this all means. The topic today is Gemini 3 Flash. It was marketed as the fast, cheap option, for quick, low-cost tasks.
Right, the simple stuff.
Exactly.
Right.
But for developers and builders, Flash is rapidly becoming the new default. It's forcing everyone, from solo founders to big tech teams, to completely rethink what budget AI actually means.
And where to spend those precious token budgets.
Our mission today is to cut through all that marketing noise. We're going to analyze the performance scores, which are pretty shocking. We'll reveal its secret weapon called dynamic thinking and run through 4 crucial real-world code tests.
And then we'll get into the playbook, how to actually use it, and maybe more importantly, what to avoid.
Okay, let's unpack this.
So DeepMind releases Gemini 3 Flash, and they position it very clearly beneath their flagship Pro model. And historically, that kind of naming implies a predictable trade-off.
Flash means fast, but maybe a little dumb. Pro means smart, but slow and expensive.
That was the rule. And Flash just fundamentally broke it, and in doing so, it really disrupted the entire pricing structure of high-level AI.
And we have the concrete evidence for this. To really quantify how big a deal this is, we have to look at the benchmark that coders actually care about. SWE-bench verified.
And this isn't just some academic test, right?
Not at all. It's not multiple choice. It forces the AI to solve real-world GitHub issues.
Yeah.
We're talking actual open-source bugs, feature requests, messy code, stuff pulled from real projects.
Yeah.
It's basically an honest job interview for the model.
And the scoreboard from that interview is what shocked everyone.
It really is. So Gemini 3 Flash, using its new thinking configuration, scored a 78.0%.
Wow.
Yeah, that's a huge figure for real-world problem solving. Now get this. Its older, more expensive sibling, Gemini 3 Pro, scored 76.2%.
So it's actually better.
It is measurably better. And Claude Sonnet 4.5 scored 77.2%. Now, technically, GPT 5.2 did nudge ahead at 80%, but there's some critical context here that makes Flash the best practical model.
Hold on a second, though. The difference between Flash and Pro, that's less than 2 points. Shouldn't we assume that small gap represents the really tricky edge cases, making Pro still necessary for critical systems?
That's a really fair point. And yes, that small percentage probably does represent problems only Pro's depth can handle. But that's where the cost comes in. That skepticism just evaporates when you look at the price tag.
Right.
We are seeing an economic collapse for high-level coding.
Right.
I mean, the cost difference is massive. Pro costs $2 per 1 million input tokens. Flash costs just 50 cents.
So the model that is measurably smarter on this key benchmark is 4 times cheaper to run. That's astonishing.
Precisely. You can run 4 complete coding iterations,
Yeah.
4 full attempts at solving a problem with Flash for the exact same price as a single run with Pro. The cost per useful output just dropped off a cliff.
How does the shift in cost versus capability fundamentally change the starting point for startups and solo builders who are constantly battling their cloud bill?
High-level AI coding is now affordable for everyone, allowing faster, cheaper iteration and experimentation.
So a nearly flagship model that's 4 times cheaper. How do they do that without killing the speed? The sources all point to this new feature, dynamic thinking, which, let's be honest, sounds a bit like marketing jargon.
It absolutely is marketing, but it also happens to describe a real architectural change.
Yeah.
Dynamic thinking forces the model to pause, plan, and internally reason about the task before it generates a single line of code.
An internal monologue.
It's a mandatory internal monologue that happens in a single API call. And you, the developer, can actually influence how much thought it puts in.
And that's critical. The old way was so frustrating. You'd ask for something complex, like a snake game, and the AI would just immediately spit out code.
Right, and it would almost always have that one fundamental bug, like the menu doesn't disappear or the collision logic is just slightly off.
Yeah.
The old model was just guessing the next word. The new way with Flash is totally different. You ask for the snake game, and internally, before writing anything, it's planning. Okay, I need a game loop, a grid, handle input, detect wall collisions, use Pygame, and then it generates the structured and usually bug-free code.
And we're seeing that planning ability shine in really serious real-work scenarios, not just little functions. I mean, refactoring a messy 800-line legacy file into clean modules or debugging a failing auth flow where the problem isn't obvious. Honestly, I still wrestle with prompt drift myself sometimes, where you prompt the AI, and by the third turn, it's completely forgotten the original constraints.
Yeah, that's a common struggle.
So seeing the model handle that internal planning, especially with constraints like build rate limiting for 10K requests per second and you have to use Redis, it's a massive relief.
If the model is handling this internal structured planning, what is the single biggest benefit for a developer's daily workflow?
The model stops being a simple snippet machine and starts acting like an efficient, guided technical assistant.
Okay, benchmarks are great for headlines, but what about production? We need to know if Flash is actually stable and useful when the pressure is on. So let's review these 4 gauntlet tests.
Test number 1 was all about speed latency under pressure, and the prompt was surprisingly complex. Create a single file HTML 3.js scene of a cozy, softly lit living room with an animated Tom and Jerry SVG loop playing on a 3D TV.
Wow, so that's testing graphics, animation, library knowledge all at once.
Yeah.
And Flash was faster than the last generation, Gemini 2.5 Pro under 30 seconds versus 47 seconds.
And that low latency is so important. It's the difference between an assistant that keeps you in the flow and one that just, makes you wait and gets annoying.
Right, you lose your train of thought.
And here's the surprise. Flash's result was actually better than 2.5 Pro and even 3 Pro. Though, I have to point out, the testers did note one clear flaw.
What was that?
There was no TV stand. The television was just levitating in the middle of the room.
Ah, the classic floating television problem. That tells you everything, doesn't it? It nailed the complex rendering and animation, but forgot basic physics. Still needs a human editor to remember gravity.
Exactly. Then there was the stress test, combining complex math with animation.
Right, this one was a 3D visualization of relative scale
Sure.
from a subatomic particle all the way up to a galaxy. It demands math, physics, animation, JavaScript, all working together perfectly.
And Flash delivered the result in the shortest time. It was great. Though the highest-end model, 3 Pro, did have a bit more polish on the final result. Flash just prioritized being correct and fast.
And that brings us to test number 4, which for me is the most impressive one, the one-shot voxel art test, the eagle test.
This prompt asked the model to write voxel art code for an eagle sitting on a branch in a single HTML file. And voxel art is really hard because you have to manually define the 3D space, coordinate by coordinate.
Whoa! Just imagine scaling a model that can handle that level of creativity, abstract spatial reasoning, and obscure library knowledge in one shot, correctly defining the relationship between the eagle and the branch in 3D space. That's a fundamentally new capability for a so-called budget model.
So the summary from all these tests is pretty clear. Flash prioritizes speed, correctness, and just pure practicality. Pro is still there for depth, creative polish, and complex framing, but Flash hits that sweet spot for just getting things built.
Beyond the raw scores and the cool animations, what single practical outcome makes Flash feel truly production-ready right now?
It's fast enough to integrate directly into your flow while being smart enough to confidently handle surprisingly complex multi-step tasks. Okay, knowing the model is great is one thing. Deploying it without setting your credit card on fire requires a real strategy. So let's talk playbook.
First thing, the API parameter. It's vital for cost control. Gemini 3 models use thinking levels instead of the old difficult thinking budget where you had to guess how many tokens it needed.
Right. Thinking levels makes it way simpler. For simple chat, you'd use minimal. But for coding, the key is to always use thinking level high. This forces it to do that internal planning.
And this is where we have to issue a strong warning. This is the minimal trap. You can't actually completely disable the thinking. Even on minimal, if the model thinks a prompt is tricky, it might still generate those reasoning tokens, the thinking trace.
So your application logic has to be ready for that. If your code expects just raw text and it gets the model's internal monologue mixed in, your app could crash. You have to be ready to parse that.
The real secret, though, for both cost and efficiency, is the golden architecture, the manager-worker pattern.
Right. So you use Pro as the manager, the architect, for maybe 10% of your tasks, high-level planning, complex reasoning, the big picture stuff.
Then use Flash as the worker, the executor, for the other 90%. It executes the plan, runs the code, processes the data. You just don't use the expensive model to change a button color when Flash can do it perfectly in a fraction of the time.
What is the ratio we should remember when architecting a new application using this pattern?
Follow the rule of 90% Flash for execution and 10% Pro for high-level, complex planning and architectural strategy. Flash isn't just another update. It's a really strong signal about where AI development is headed. If you connect the dots, there are like 4 major shifts happening right now because of this.
Okay, so signal number 1. Pro-level intelligence is becoming incredibly cheap. That old line between fast and basic and expensive and powerful, it's just collapsed.
And that means low-cost models will soon handle things that were just too expensive before. Imagine an AI reviewing every single pull request, or live, continuous refactoring happening right inside your editor without you even thinking about the bill.
Signal 2. Models are actually learning how to think. This dynamic thinking is part of a trend where models move beyond just guessing the next word. We should expect models that debug their own code, or agents that can plan multi-day development tasks.
And that completely changes your role as a builder. You spend less time on boilerplate and more time deciding what should be built and why. You move up the stack to strategy.
Signal 3. Speed is the new battleground. Accuracy used to be everything, but now the focus is on latency. A slow suggestion breaks your flow. The future is near-instant responses that feel like a native part of your editor.
And signal 4 is that development is opening up to everyone. When strong coding AI costs almost nothing, the friction to build something is basically zero. Solo builders can ship complex products. Non-technical founders can prototype real ideas. Junior devs get senior-level support instantly.
If the quality and cost of the tools are no longer the problem, what is the core question that remains for developers?
The only remaining question is what you, the builder, choose to build with this new democratized power.
Okay, so Flash is incredibly powerful, but we have to be really clear. It is not a magic bullet. And running into these limits will cause some painful, expensive mistakes if you treat it as flawless.
Limitation number 1. Very long contexts. Flash still struggles when you push it into millions of tokens. It works best in that 2,000 to 8,000 token range. Beyond that, it starts missing details.
The fix is to break up your big code bases into chunks and always include a short architecture summary in every prompt to keep it on track.
Limitation 2. New or bleeding-edge frameworks. Flash only knows stuff up to its training cutoff. If you're using a brand new framework, it might suggest outdated or just wrong patterns.
So you have to bring the framework to Flash, paste the relevant docs right into the context window, and be explicit. Tell it, use this exact Astro 5.0 API, not the old ones.
Limitation 4 is a classic LLM problem. Confident answers to vague prompts. If you're unclear, it'll just make an assumption and give you a confident but potentially incorrect answer.
The fix is to treat your prompt like a strict contract. Define your preconditions and postconditions. Don't just say, handle the date. Say, if date parsing fails, log a warning and return. None. Clear rules, safer output.
And finally, number 5, security and privacy. Flash runs on external infrastructure. Never, ever send secrets, API keys, credentials, sensitive business logic in clear text.
The safe ways are to anonymize your code, use Google's enterprise tier, or run it through something like Vertex AI for more control. This is not your private notebook.
Which limitation, if ignored, poses the greatest immediate risk to a real-world deployed application?
Ignoring security and privacy rules, or treating external infrastructure like a private notebook, is without question the biggest risk. So Gemini 3 Flash is a rare, genuinely paradigm-shifting upgrade. It's faster, it's demonstrably smarter than its sibling, and critically, it's 4 times cheaper. It breaks that budget model trade-off we've all been living with. You get high-level intelligence with high speed and low cost, and this changes developer behavior instantly. Complex tasks like refactoring or debugging now feel safe to hand off to an AI because the cost is so low, you just start experimenting.
The budget model really has become the king of code. And this leads us to our final provocative thought for you. The sources suggest trying to flash out in Google AI Studio for the best control. So here's a thought. If AI can now handle complex spatial reasoning and code architecture for pennies, how long until the cost of computational creativity becomes virtually zero? And what is the next high-value, uniquely human skill that developers will need to cultivate to stay relevant?
That is the essential question to build on. And if you want to experience this dynamic thinking firsthand, go try running one of those gauntlet tests we talked about, the voxelar eagle or the complex scale animation. That'll really show you what this new architecture can do. Thank you for sharing your sources and letting us take this deep dive with you. We'll catch you next time.